The Maya Train is an ambitious infrastructure project with a €2 billion budget, initiated by the President of Mexico to stimulate socio-economic growth and boost tourism in the Yucatan Peninsula. The project encompasses a 1,554-kilometer railway corridor for passengers and freight, divided into 7 sections. It will improve connectivity between the 5 southeastern Mexican states, Chiapas, Tabasco, Campeche, Yucatan and Quintana Roo. Construcciones Urales, ASVI's Mexican subsidiary, in partnership with Grupo Indi, is responsible for Section 3 and Section 5 South Subsection B, as well as the construction of the workshops and train sheds. The combined value of these 3 contracts totals €2 billion. The project, which involved simultaneous design, engineering and construction, was completed in a record time of 24 months. This was possible thanks to the relentless efforts of 400 individuals who worked around the clock to meet the deadline set by President Andrés Manuel López Obrador, December 2023. In May 2020, following an international public tender process, Fonatur awarded the Asvendi Consortium a €1.2 billion contract for the design and construction of Section 3. The section includes 160 kilometers of track designed for passenger trains reaching speeds of up to 160 kilometers per hour. Additionally, the contract included infrastructure conservation and maintenance for a minimum 5-year period and the construction of a railway maintenance hub to guarantee the running of trains at the start of commissioning. Section 3 of the Maya Train runs between Calcani in Campeche State and Izamal in Yucatan, bypassing the city of Mérida. Along its length, the project includes 6 stations located in key settlements of the ancient Mayan civilization. It is at these points that infrastructure and mobility converge with economic development and tourism in the region. As well as the stations at Calcani and Izamal, the consortium constructed stations in Maxcanu, Umorn, Tixkokob, and most significantly, Mérida. The environment and archaeology in the southeast of Mexico are key considerations which were respected throughout the design and construction of the Maya Train. Preserving archaeological remains was a priority to ensure the safeguarding of the region's cultural and archaeological heritage. A series of protocols outlined by the National Institute of Archaeology and History were meticulously followed, depending on the location of the artifacts. Along the length of the project, 4,500 relics were uncovered and preserved, ranging from small Mayan artifacts such as pottery and tools, to larger relics. All of these finds will be displayed in the Catvis visitor reception centers which are also being built along the route. This interest in safeguarding the area's archaeology is complemented by the Promesa Archaeological Improvement Program, included in the scope of Asvendi's works. To minimize the environmental impact of the infrastructures, the project was designed with a minimum slope involving limited earthworks. The entire route runs along an embankment which required 7 million metric tons of material for its construction, sourced from borrow pits along the route. The 160 kilometers of Section 3 are divided into 100 kilometers of single track and 60 kilometers of double track. In a region such as the Yucatan Peninsula, one of the project's challenges was the logistical difficulty involved in transporting materials and teams to the site. To complete the superstructure, 950,000 tons of ballast were extracted from 8 borrow pits located in Veracruz and Tamaulipas in Mexico, and Tarragona in Spain. The material was stockpiled at 4 strategic points along the section to facilitate supply. A factory was built on site to supply Section 3 with the necessary sleepers and ensure the project remained on deadline. The plant's production capacity was 80 sleepers per hour and peak projected performance was 1,600 sleepers per day. The design, construction and operation of the factory and the design and certification of the sleepers were carried out using in-house resources, making it one of the most state-of-the-art factories in Latin America. Additionally, the factory's workforce was made up of a substantial number of female workers, in line with ASV's commitment to equal opportunities. A total of 238 kilometers of track, using 25,000 tons of rails were necessary for the assembly of Section 3 of the Maya train. 100 kilometers of single track on the Kalkani-Merida-Taya section, 60 kilometers of double track on the Merida-Taya-Izamil section, 18 kilometers of single track in stations and sidings. Additionally, 96 custom-designed and manufactured track mechanisms were installed to permit the transit of both passenger and freight rolling stock. The track assembly process required 6 welding robots to complete 16,447 electrical welds and 1,466 aluminothermic welds. A key milestone in the execution of this section was the arrival of ASV's heavy machinery and machinists in Mexico. The high demands on resources to meet the tight deadlines set by the client led ASV to ship part of its machinery fleet to the Maya train, with the first machines arriving in April 2022. Both the machinery and ASV's outstanding team of machinists, including 9 Mexican operators who underwent extensive training in Spain, were crucial to the progress and success of this project. Without them, the completion of the project would never have been possible. The electrification system was installed by Kupiza, the subsidiary of Construcciones Urales, which specializes in technological and electromechanical systems. The electrification system uses Type ABC 350 catenary for speeds of up to 160 km per hour. 3 different viaducts were built to cross the access roads at Merida Cancun and Merida Camchi. The most significant is the 128-meter-long viaduct over the Merida-Camchi Highway. To ensure transverse permeability, 34 vehicle crossings, 73 underpasses and 80 wildlife crossings were constructed, along with transverse drainage systems. The completion of the Maya train Section 3 required large-scale commitment from professionals and machinery. Over 12,000 direct jobs were created for construction workers and administrative staff. Over 1,000 machines were required. The Maya train will feature 6 strategic points along its route where its rolling stock will be stored and maintained in optimum conditions. In June 2021, Fonatur and the consortium of Bombardier, Alstom, Gamma Ingenieria, Construcciones Urales and Kupiza signed a €1.6 billion multi-year contract for the acquisition of rolling stock and railway systems for the Maya train. The system of workshops and train sheds includes 6 modern facilities with state-of-the-art equipment to house and maintain 42 trains in different combinations. 3 depots are located in Camchi, Merida and Tulum, while the other 3 workshop and depots facilities are located in Cancun, Chetumal and Escarcega. The workshops and train sheds operate 24 hours a day, 365 days a year. The contract also included the construction of railway signaling, communication and safety services along the length of the network. Construcciones Urales was responsible for all civil works on the 1,554-kilometer corridor. The design and construction of these services, as well as the planning and logistics for an area twice the size of Andalusia, made these works a challenge in the construction world. The investment in civil works for the project was close to €650 million. ASV and Construcciones Urales' involvement in the Maya train concludes with the construction of the infrastructure and catenary system for part of subsection B, Section 5 South, with a budget of €150 million. This 21-kilometer subsection connects Acumal and Palmul, crossing the Yucatán rainforest, in Quintana Roo state. The challenge of this project was the elevated level of karst in the area. First-class engineering was required as surface and groundwater erodes the rock, creating galleries and caves that lead to sinkholes in some areas. As a result of the unique qualities of this area, 2 solutions were employed for the construction of infrastructure. Firstly, an embankment was built and assembled on a concrete slab. Secondly, a pile-supported viaduct will provide the necessary stability for the track. The Maya train is the best-equipped railway in the country, and sets a benchmark for future developments in railway infrastructures in Mexico. With the participation of Construcciones Urales, Cupisa and ASVI in this vast project, Grupo ASVI once again plays a key role in the construction of a landmark railway corridor. The company's century-long expertise in the development and construction of this type of infrastructure, its technical capability, commitment to high standards, and dedicated workforce are evident. These are the keys to the success of iconic projects such as the Maya train.